Hello everyone, I'm Karthik Gopalan. In this lecture, we will cover the topic of system calls. System calls are interfaces provided by the operating system to user level processes. Processes can use system calls to ask the operating system to perform privileged operations such as performing I/O operations on hardware devices or accessing any shared resources. Modern CPUs support at least two privilege levels. One is the user mode where normal user level processes execute, and other is the supervisor mode where the operating system's code executes. So system calls involve a transition from user mode to supervisor mode when a process makes a system call. And then once the system call completes, then the CPU privilege level changes back from supervisor mode back to user mode. The operating system maintains a data structure called a system call table in which it records various entry points into the kernel for executing these system calls. So there are many different system calls supported by operating system, and for each system call there will be a function pointer in each entry of this system call table. So normally user level applications will provide a system call number, and the operating system will use the system call number to look up the corresponding function pointer in the system call table and invoke that function pointer for the corresponding operation. A more detailed description of the system call invocation is as follows. Applications request a system call by invoking a special instruction. For example, there is the sysenter instruction that is supported on x86 processors. Older x86 processors did not have such an instruction, so operating systems would then use the uh, soft interrupt x80 instruction, and other processors support instructions such as lcall 7, lcall 27, and so forth. So the system call number and the arguments required by the system call, they are passed through various registers and optionally the user process own stack. So once the system call is invoked, then in step 2, the CPU recognizes that this is a special instruction and it would save the process execution state so that it can return to that state at a later time. The CPU then switches the privilege level to the supervisor mode and then jumps to an entry point in the operating system code, which then executes with the supervisor mode privileges. At this point, the operating system would then look up the system call number in step 4, and it would index into the system call table to find the corresponding function pointer for that system call. In step 5, the OS then invokes the system call that will implement the services required by the user level process. So one point to note here is that for performance reasons, the system call, which is executing as part of the OS code, is still executing in the execution context of the process which requested the system call. So we are not switching from one process context to another execution context as we normally do with inter-process context switching. Here, the CPU still stays in the execution context of the calling process. In some operating systems, this mechanism may be slightly different. For security reasons, operating system may execute in a separate execution context, and system call invocation may involve context switch, a full context switch into the OS context. So keeping this in mind, in step 6, we see that if the system call involves a blocking I/O operation, for example, if you have to read data from a file on the disk, which may take a long time, then during this time, instead of wasting CPU cycles, the calling process may be placed in a blocked state. If you recall our process diagram consisting of ready running and blocked state. So here the process was in a running state when it made the system call. Now let's say you need you need to wait for an I/O operation. At this point, the process will be moved to blocked state so that CPU is free for doing other tasks. At some point, now we are in step 7, at some point when the system call completes, then the process is then moved back into the ready state, where it then waits for its turn to execute on the CPU. Once the process starts running, once it's a time for the process to run again, at this point, the state that we saved earlier in step number 2, that execution state is restored. The CPU then switches back to the user mode privilege level, and then it returns back to the calling location using some special instruction. For example, the sysexit instruction in x86 would switch the execution privilege level from kernel mode to user mode. And on older operating system implementations, sometimes the iret instruction is used. So once the process returns from system call in step 10, then it continues doing whatever it was supposed to do. So this is the entire execution flow for how a system call is invoked and how you return back. The specific details may vary from operating system to operating system and from architecture to architecture, but generally this provides a framework for understanding how system calls operate. As a final note, uh, we'll talk about how user level applications uh, see a system call. Normally, when you write a user level program, you don't directly invoke a sysenter instruction, which is in assembly. Instead, you invoke library routines. For example, if you want to fork a process, you invoke a library routine for fork operation. So these library routines are like wrappers, and within these library routines, the specific system call number and the specific arguments, if the system call takes an argument like open or close, then the system call number and the arguments are packed together in registers or on the process stack, and then finally the sysenter instruction is invoked to make the transition from user space to kernel space. So this increases the portability of your program. So you don't have to rewrite your user level code just because your CPU runs on a different architecture where the system call instruction is different. Uh, Instead you just compile your program against the library that's meant for that specific platform. All right. So the slides that follow here are specific details, programming details of how you would go about implementing a new system call in the Linux operating system. I'm not going to cover the details, programming details in this recorded lecture, but feel free to browse these slides. There are many online resources as well that you can search. Feel free to try this out in a downloaded version of Linux kernel. And if you have any questions, feel free to ask me.